the fourth unit is integrals. The first topic that you have is Riemann integrals, and then you'll be having properties of Riemann integral, and then theorems on calculus. So first, let us look into the definition of Riemann integral. Before moving on to the definition of Riemann integral, there are few important definitions that you have to know. So the first definition is partition. The first definition is partition. So let us consider a closed interval, that is a comma b, with a should be strictly less than b. Okay, considering the closed interval ab with a less than b. So this is written as a is equals to x naught less than x1 less than x2 and so on up to xn, which is equals to b. And before xn, you'll be having xn minus 1 and so on. So we have to write this interval in such a way that you get a equals to x naught less than x1 less than x2 and so on up to xn is equals to b. Okay, so this is a finite set. This, then a finite set. What is a finite set? We have from x naught to xn. So this is equals to x naught, x1, so on up to xn. This is called a partition. This is a partition. Partition of what? Partition of the closed interval AB. So this is a partition of the closed interval A comma B. And how is this denoted? As partition starts with P, they are denoting it as P itself. So the partition is denoted by P. Now tell me, what is this called in this case? Like if you have x naught, x1, x2, so on up to xn minus 1, xn. What are these all called? They are called n plus 1 partitions. Why is it called n plus 1? If you have x naught, x1, x2 and so on up to xn minus 1 and xn. This is called n plus 1 partitions. Why is it n plus 1? See, from x1 to xn, you have n terms. You have n terms by adding x naught plus 1. So this is n plus 1. You'll be having n plus 1 partition points. Okay. So in this, you'll be having n plus 1 partition points. Now coming to the intervals, as we have, like this set contains n plus 1 partition points. Now talking about the intervals. Now see, like you just have a real line. This contains some x naught, x1, x2 and so on up to xn. Obviously xn is b and x naught is equals to a. So what will be the intervals? The interval will be from x naught to x1, x1 to x2 and so on xn minus 1 to xn. So what is this interval? This is the first interval I1. This is the second interval I2 and so on. This will be the nth interval In. So how is that we have to write? We'll just write I1 is equals to x naught comma x1. I1 is equals to x naught comma x1. What is I2? I2 is equals to x1 comma x2. And what is In? So on up to In, the interval In. In will be xn minus 1 comma xn. Okay. These are known as n subintervals. All these are known as n subintervals of the partition. So just write these are known as n subintervals of the partition. Am I clear till here? Next. Or they are also known as segments. Okay. Either they are known as partition or they are written as segments of a closed interval a comma b. Now coming to, like till now we had In is equals to In minus 1. What if we have r subintervals? What if we have r subintervals? If you have rth subinterval, then how is that? That is going to denote, it is denoted by IR. So this IR is going to be XR minus 1 comma XR. What is the nth subinterval? It is written as xn minus 1 comma xn. So instead of n, we are just writing it r. So IR is equals to XR minus 1 comma XR and delta R. So delta, the length of the partition is denoted by delta R. Okay, so this delta R is equals to XR minus XR minus 1. That is, if this is A comma B, delta will be B minus A. Just remember that if the closed interval is A comma B, then length is B minus A. Am I clear till here? What is that we have learned? First, we have learned the interval. We just took the interval, and then we had subintervals. If we had rth subinterval, then it is denoted by IR. And then we have learned about length of the partition. Now there is an important note. The note says for every closed interval A comma B, there exist infinitely many partitions. For closed interval A comma B, there exist infinitely many partitions. Okay, there are infinitely many partitions. Then set of all partitions are denoted by phi of A comma B. Set of all partitions are denoted like this. That is phi of A comma B. Okay, we just learned about the interval, and then we learned about subinterval, and then we have learned about the length of the partition, and we learned the note. What is the note point? In between A and B, closed interval AB, there exist infinitely many partitions, and that set of all partitions is denoted by phi of A comma B. Now moving on to the next definition, that is norm of the partition. Norm of the partition. You know what is partition? It should be between A comma B, then it will have subintervals, then it will have length of the partition. Now coming to the norm of the partition, it says the maximum of length, that is the maximum of length of each subinterval. Each subinterval, the maximum of the length of each subinterval of what? Subinterval will be in partition. So it should be in partition. Each subinterval of partition P. How is that denoted? Partition is denoted by P. This is called norm of the partition. It is called norm of partition. And it is denoted by like this. This is denoted like this. Norm of P is like this. Note point. Summation R is equals to 1 to alpha, that is delta R is equals to B minus A. In the before slide, I just told you delta R is denoted like this, like length, no, B minus A. It is denoted by, if A comma B is there, how will you write the length? Delta is equals to B minus A. So that is what they wrote. It is B minus A. Okay. This is an important note point. Now, even in this, you'll be having upper Riemann sum or upper Darboux sum. Okay. You'll be having both upper Riemann sum or upper Darboux sum. And in a similar way, you'll be having lower Riemann sum and lower Darboux sum. We'll just look into that definition. What is that? Upper RS is Riemann sum, or it is also known as upper Darboux sum. Oh, and lower Riemann sum or lower Darboux sum. So how is these lowers and uppers defined in a partition or in a Riemann integration is, if there is a function f which is bounded. So I hope you all remember the definition of bounded. So if f is bounded, where on the closed interval A comma B, it should be bounded in this interval itself. And what is a partition? P is equals to A is equals to x0, x1, so on up to xn is equals to B. Okay. If F is bounded on closed interval AB and P is the partition, let P be partition of closed interval A comma B. And what is the subinterval? Rth subinterval, because we defined IR. So let IR be the rth subinterval. How will we define that one? IR is equals to XR minus 1 comma, this is minus 1, XR minus 1 comma XR. Okay. And then the length. What is length? Delta R is the length. Delta R is length of it. Length of it and the length of what? A comma B, that is B minus A. So what are the things that we took? First thing, F should be bounded on AB. Then we took the partition, and then we spoke about the subinterval, and then we took length. We took 4 things. First is F is bounded, and then the partition, and then the subinterval, and then the length of the interval, that is A comma B. Now let capital MR and small mr. What is capital M and small m? Be supremums and infimum. Supremum and infimum. Least upper bound and greatest lower bound. Supremum and infimum of what? We are talking about F. So of F. That is the function. On where are we talking? This F is on where? On the subinterval IR. So on each IR. Okay. Then the sum. What is the sum? The sum capital M1 into delta 1 plus capital M2 into delta 2. What are deltas? Delta is the length of the interval. So M1 delta 1 plus M2 delta 2 plus so on up to Mn delta n. What is this called? This is called upper Riemann sum. This is upper Riemann sum. Okay. How is this denoted? The upper Riemann sum is denoted by UPF. Upper Riemann sum is equals to summation R is equals to 1 to n capital capital MR to delta R. This is the representation of upper Riemann sum. Okay, in the same way we have to define lower. How will you define lower Riemann sum? The first one is the sum, that is small m1 delta 1 plus m2 delta 2 plus so on up to mn delta n. Okay, this is called the lower Riemann sum. RS is Riemann sum. How is this defined? LPF. LPF is equals to summation R equals to 1 to n small mr into delta R. Okay, this is the definition of upper Riemann sum and lower Riemann sum. The next definition and the very important definition is oscillatory sum. What is an oscillatory sum? Oscillatory sum. So what does this mean? Same definition. F should be bounded. F is bounded. I'm just writing it in the short form. B and A is bounded on closed interval A comma B. And then what are we actually talking about? The main concept is partition. So P equals to x0, x1, so on up to xn be the partition where on the interval, closed interval A comma B. Then now comes the important line, that is UPF minus LPF. UPS minus LPF is associatory sum. That is oscillatory sum. And then how is this denoted? Oscillatory starts with O. So remember like that. It is denoted as O of P comma C or omega of P comma C. Okay. It is denoted like this. Now we'll just look into one problem. Then you'll have a clear idea what is lower sum, what is upper Riemann sum, etc. etc. They gave one interval. I is equals to 0, 4. And then they asked us to calculate norm P. And they gave the first question as P is equals to P1 equals to 0, 1, 2, 4. And the second question P2 is equals to 0, 1, 1.5, 2, 3.4 and 4. And then third one they gave P3 is equals to 0, 0.5, 2.5, 3.5 and 4. And P4 is equals to 0, 2, 3, 4. I'll just do the first question, and the next three questions you just try by yourself and let me know what is the answer that you got. So moving on to the solution, they gave P1. What is P1? 0, 1, 2, 4. What is this? This is a partition. Partition where? On 0, 4. So what will be the intervals? Tell me. If you draw 0, 1, 2 and then 4. So what will be the intervals? Here to here, here to here and here to here. So what is I1? I1 is equals to 0, 1. I2 is equals to 1, 2. I3 is equals to 2, 4. All these are subintervals. All these are subintervals. Subintervals of I is equals to 0, 4. These all are the subintervals of what? I equals to 0, 4. Now we have to find the length. What is length? How is that denoted? It is denoted as delta 1. Delta 1. What is actually, like if you have a comma b, what is delta? Delta is b minus a. Now here b minus a is 1 minus 0. That is 1 minus 0 equals to 1. What is delta 2? Delta is 2 minus 1. 2 minus 2 is 2 minus 1 is 1. Delta 3 equals to 4 minus 2, that is equals to 2. Now what is norm P? Norm P is equals to maximum of delta 1, delta 2 and delta 3. So what is that? Maximum of 1, 1 and 2. So what is maximum of 1, 1 and 2? 2. So this is the norm P. So norm P is equals to 2. In the same way, you just try second, third and fourth question. Here the answer will be equals to, in the second one, the answer will be 1.4. In the third one, it will be 2. In fourth one, this will be 2. Okay. Now let us look into the next problem. That is, if f of x, like if they gave any f of x, if f of x is equals to x square and p is equals to 0. Partition they gave 0, 1 by 4, 1 by 2, 1. Let this be the partition, be a partition on 0, 1. So they gave f of x, the function, and they gave the partition. Now they are asking us to find LPF and UPF. LPF and UPF. So how will you find that one? First, what is that they gave? Solution. They have given that f of x is equals to x square. F of x is equals to x square. And then what is the partition? P is equals to 0, 1 by 4, 1 by 2 and 1. This is the partition. On where? On 0, 1. So what will be the intervals? Tell me. What is I1? I1 equals to 0, 1 by 4. I2 is equals to 1 by 2, 1 by 4. And I3 is equals to 1, 1 by 2. Are subintervals where of 0, 1. These are the subintervals of 0, 1. In the same way, find length. So length of I1, that is delta 1 is equals to 1 by 4 minus 0. So what is that? 1 by 4. What will delta 2 be? Delta 2 is equals to 1 by 4 minus 1 by 2. So this is equals to 1 by 4. And delta 3 is equals to 1 by 2 minus 1. This is equals to 1 by 2. What is that we have to find? LPF and UPF. So let us consider capital MR and small mr as infimums and supremum. Let this be supremum and let this be infimum for every IR. That is, we have to find for I1, I2 and I3 as we have 3 subintervals. Okay. So what is M1? How will you write M1? I hope you remember the formula of M1s. M1 delta 1 plus M2 delta 2 plus M3 delta 3. So what is this one? What is capital M1 over here? Capital M will be, like, you have to put the values over here. 1 by 4 square, that is 1. This is 1 by 4 into 1 by 4. So M1 will be 1 second. Delta is, yeah, M1 will be 16. Sorry, M1. Separate M1. That is the, so here capital M1 will be equals to 1 by 16 and small m1 will be equals to 0. That is, you got to put these values. I1 is 0. 0 is infimum and 1 by 4 is supremum. If you put it in the function x square, 1 by 4 is 16, 0 square is 0. So what will m2 be? Capital M2. M2 is 1 by 4. Put it in this, you'll have 1 by, sorry, here supremum is 1 by 2 and infimum is 1 by 4. So if you put 1 by 2 in x square, 1 by 2 square, that is 1 by 4. And small m2 will be equals to 1 by 16 because 1 by 4 into 1 by 4. And capital M3 will be equals to 1 and small m3 will be equals to 1 by 4. Okay. Now we have to write the definition. Just remember these values of 1 by m1, m2, m3. So now what is UPF? UPF is equals to summation R equals to 1 to 3. So that is capital MR into delta R. That is equals to M1 delta 1 plus M2 delta 2 plus M3 into delta 3. So what are M1 and delta 1 values? 1 by 16 into, what is delta value? Delta 1 is equals to 1 by 4. 1 by 4 plus what is M2? 1 by 4 into 1 by 4. 1 by 4 into 1 by 4. And then M3 is 1 by 2. In M3 is 1 into 1 by 2. M3 is 1 into 1 by 2. So the value for this will be equals to 37 by 64. So what is UPF? UPF is 37 by 64. Now finding LPF. LPF will be equals to summation R equals to 1 to 3 small mr into delta R. So this is equals to small m1 delta 1 plus small m2 delta 2 plus small m3 into delta 3. What is m1? M1 is 0. What is delta 1? 1 by 4. What is small m2? 1 by 16. What is delta 2? 1 by 4. And then what is M3? M3 is 1 by 4 into, what is delta 3? 1 by 2. So if you calculate, what is the value that you are going to get? Somewhere around 9 by 64 or something. Okay, this is what you have to find, LPF and UPF. I'll give you 3 homework problems. Just try it by yourself and let me know.
Excuse me, ma'am.
Yeah.